Right. A few months ago, I gave a talk at a CSRW. Have I got that right? And Seth Bullock was very kind and said my talk was provocative. Others said it was offensive. So I just like to try and maintain this kind of middle ground. How many economists are here? Any economists? Okay. Well, there's only one of you.
There's one, but he wanted to know
Two. Oh, well, I won't have to worry about you then. They're not enough for you to cause trouble. Now, I also have to confess, I think that PowerPoint sucks. I hate it. I mean, I've come to use it, and I do use it, and I will use it, but I'm going to, don't rely too much on it, because I'm hoping to sort of have a more freewheeling conversation. I'd really quite like to involve the rest of you in it. One of my kind of bête noire is people who interpret Occam's razor to mean that a simpler theory is a better theory. A, it's not what Occam said, if indeed he said anything about it. What he said was, if you have a bad model, complicating it doesn't improve it. But the other thing is that people who, and I have to say particularly economists, one of whose cheap shots at the work that I and many of you do is that the models aren't simple. So I want to talk about that. One of the things I was taught as a student in Cambridge in around about 1970, some of you may not remember, was that it is not respectable to appeal to authority for what you say. By all means, cite your progenitors, but because someone said it before you, because someone famous said it before you, doesn't mean that it's right, okay? Which is obviously why I've chosen that quote from Einstein. Okay, you know, we hear all kinds of things about it. Well, he said, you know, a theory should be as simple as possible, but no more simple, or as complicated as necessary, but no more complicated, and so on. But that's what he said. And I subscribe to this, not because Einstein said it, I have to tell you. I'm just telling you this is a starting point for me and has been for a very long time. And particularly the last bit. Simple and few as possible, I'm happy to do that, without having to surrender the adequate representation of a single datum of experience. So what is the datum of experience? What are we looking at? For me, the data of experience are what I'm told, basically, by stakeholders, by people who know what they're talking about, experts, domain experts. Okay? It's documentary evidence. That's what I rely on. That's what constrains the models I build. Okay? What does not constrain the models I build is any social theory that has not been very well validated in the widest possible range of contexts by the widest possible means. Okay? So I do rely on some results of cognitive science, and I do rely on results from social psychology. Right? And the results that I rely on and have done for very many years, probably about 40 years, from social psychology are now very close to what complexity scientists rely on. That is to say, it is common to my models that I assume that individuals are most influenced by those who are most like them. Okay? And there's plenty of evidence for that from social psychology. Okay? It is also an important precept in my work, and has become increasingly so over the years, that what I am doing is telling a story. Not just any story. I'm telling the story of someone who is trying to justify a policy or set of social actions. I'm not telling the truth, because I don't know what the truth is. I certainly don't want to get into the philosophical debates about what is truth. All I want to do is to produce some scenarios which are based on models that are plausible to people who are seeking a particular outcome. And sometimes the models don't produce the outcomes that they want. And I will typically ask, is it the model? Have I done something wrong? Or is your preferred and expected outcome not something that you would necessarily expect from what you have told me about the way the world works? And I don't think there has been a case yet in which they've agreed that they were wrong. There's always, my model somehow fails to capture it. I can tell you some stories about that, but I won't. Okay. So the purpose of a model, from my point of view, is to make clear, precise, and unambiguous the elements of the stories that people tell in order to justify their personal policy preferences. If you want anything more from a model, it's not what I'm doing. Okay. Well, let me see what my next slide is. Oh, right, there's a kind of outline, but I don't think I'm going to follow it. Okay, so let's have some terminology. Because, in particular, I have this slide because words like complexity and complicated tend to get used in very funny ways, not properly distinguished. This is what I'm going to mean by simple, complicated, and complex. Okay? A model is simpler as it has fewer entities, say fewer kinds of agents, not number of agents, but kinds of agents, fewer social objects that they relate to, maybe institutions or roles or whatever, and fewer links amongst them. Then they're simpler. Also, I want you to imagine, though I'll show you one later on, a graph, let's say a mathematical graph, a network, if you like, of rules, where you have conditions that describe the state of the world, and then those conditions link to a rule, and the rule will be fired, as we say, will be activated when the conditions are met, and then it will produce more conditions, and the rules that produce these conditions then enable other rules to fire, and so on. Okay, so you have this kind of network. I'll show you one later on, but I think you can imagine what I'm talking about. Maybe I'm just more visual in the way I think of these things than most people, but that's what I have in mind. I'll show you one later on. So that's what I mean by fewer rules describing agent behavior and dependency. The spectrum, if there is one, though it's not quantitatively ordered, is from simple to complicated, not simple to complex. It's complex on the basis of social interaction, leading to macro-level results that cannot be predicted from individual behavior alone. Okay. Oh, isn't that cool? This is an actor network diagram. I don't know what to do about that. Got it? I don't know, can you see it? Yeah, okay. Right, that's a fairly complicated one. Let's move on. Oh yeah, I remember this slide. Okay, you get the idea. There are social norms in every field, violations of which we have seen in a variety of ways. I think I was reading a lot of sort of medieval history when I came up with these two. You know, the Spanish Inquisition. But you get the idea. And this, of course, is the sanction that affects most of us most severely. I, at one point, started declining to review grant applications for the ESRC because they wouldn't fund me. They did fund the applications that I said shouldn't be funded, and they did fund those that I said shouldn't be. Sorry, did I get that? Did I get that full thing? They wouldn't fund those that I thought should be funded, and they would fund those that I thought shouldn't. So I thought, this is nonsense, right? Okay. Now, I think you can see what's going on here. This is the most important one, I think, that complicated models are difficult to build, and they're difficult to understand. And that is the argument for simplicity, right? If you're going to build a complicated model, it's hard to understand it. I find this very odd, the more I think about it. At least I have done recently. I mean, I went along with that for a long time, the way we all do. But what we're trying to do is not to understand a model. That's not the point. Right? The point is to understand something about society, about social processes. And if you're in my kind of field, it's about social policy. You want to understand the social processes that are going to determine the outcomes of your policy measures. Right? Now, these are very complicated. Why should you suppose that a simple model is going to tell you something useful about a complicated situation? Now, okay, I know everyone is going to say, but look, models are models. That's the point. They don't they're not one-to-one representations of the real world. Absolutely. How much complication do we need in order usefully to capture the social processes that are relevant to the policies that we are promoting? I don't know. And I'll bet you don't know. Why don't we know? Because no one's ever investigated it. We've all said models have to be simple, right? Because otherwise we're not going to understand the models. But we do understand some really very complicated things about the world in which we live. It's not that we can't understand complication, right? It's that we can't understand something that's really complicated all at once. We develop our understanding of extraordinarily complicated phenomena. Right? Try playing chess. Right? We know how much harder it is to get a computer program to play chess well than it is to get a person to play chess well. Right? Okay. So that seems to me to be the point. The rest of that stuff is interesting. We're not going to bother with it. Okay. Now, this is what policymakers want, this top one. They want models that are simple, they give them answers, and provide indicators. Okay? The second point is what I've just been talking about. Now, this is very, very odd to me. In the last few years, various upturns, and since the 2008 financial crisis, we've had various upturns and downturns in the economy, right? We've had possible double dips, triple dips, recoveries. They happen, they don't happen. And economic models have pretty much blanketed the calendar, right, with forecasts of every kind. It's going to go up in 6 months, it's going to go down in 6 months, it's going to 9 months, then 3 months, right? How many of those forecasts have been correct? If you're going to blanket the calendar with forecasts, just at random, one of them would be right sometime. Anybody know of a case? Right? And yet, it's not very long ago that Mervyn King justified some policy, I think it was quantitative easing, on the basis of, well, all of the models are agreed that we're going to, different changes, but they're all up or they're all down, or most of them up or all of them are down. And Nick Stern, now Lord Stern, a few years ago, produced a report for the government on climate change, which was based on analyzing the outputs from social and physical models of climate change. Okay? Now, when I left home this morning in Derbyshire, the weather forecast was snow in the north, maybe some rain in the south. I think I walked over here through some snow, didn't I? Right. Look, the 5-day forecast is not incredibly bad usually. But I'll tell you, I'm a sailor, right? And I listen to the forecasts when we're sailing, you know, the marine forecasts, and I never believe them. Never, ever. And usually I'm right. Okay. The forecasting is it's not just difficult. In practice, we don't do it. We do it badly. Right? And to rely on model forecasts for policy seems to me to be wholly unjustified. Okay? I will tell you that econometric modeling was developed by Jan Tinbergen and his team in Amsterdam in about 1934-35. And since that time, right, how many correct econometric forecasts do you think there have been of a turning point in any financial market or in any trade cycle? Guess a number. 5? Who go for 5? Anybody? 10. 3. 2. 1. Are you just being shy? 0? 0. The economists got it right. There hasn't been one. Okay.
So what do you do instead then? Because isn't that the question?
I'm going to show you. I'm going to show you. How much time do I have, by the way?
About 25 minutes.
Well, okay, I'll move on quickly. Yeah, okay. Read that quickly, please. Got it? That's what you do with models. Software requirements. Okay, what I was talking about was we don't understand. You know, we do understand complicated things, but we don't understand them all at once. And to require a model to be understood all at once is just to place an artificial restriction on what we do, and one that in practice is not useful. Okay? But what we need to be able to do is to incrementally not just develop our models, which is what we all do anyway, surely, right? But also to provide a means for stakeholders, for our clients, right, also to build up an understanding incrementally. Not to build up an understanding of the model, though they may, right, but to use the results of the model and maybe the model design to formulate an understanding of the social processes that are relevant to the determination of the results, the impacts of their policy measures. Okay, that's my point. Yeah, okay. I think I've said that. Okay, yeah, this shows up. Okay. Now, Kokomo, there are two pronunciations, a Kokomo and Okapomo. I go for a Kokomo. We have a load of documentary evidence, okay? Interviews, PDF files, HTML files, text files, all that kind of stuff. Now we use it to create a model design. CCD is either conceptually consistent or consistent conceptual design. Okay. We then have a neat bit of code that automatically produces some model source code. Okay. Now the source code is partly Java and partly a declarative rule-based agent modeling environment system called DRAMS, declarative rule-based agent modeling, DRAMS, got it? And a lot of that happens automatically. All of the Java code, which is basically a repass model. Anybody here who doesn't know about repass models? It's okay not to know, just tell me. Okay. There is quite a commonly used library, Java library, for agent-based modeling, okay? Where it does all the scheduling for you, is really what it does. You set up the model within it. So it writes that code for you. It writes all of that code for you. Let's say it writes the code that implements each type of agent, the number of each type of the instances of each type of agent. It sets up the model. It also reads in files to that drive the behavior of the agents, stuff like that. Okay. You then run the model, which produces outputs. Okay. Now these outputs are from print statements of various kinds. Some of the print statements are XML. Some of them are in the form of CSV files, for putting into Excel and the like. Some of them are XML files for producing graphs, visualizations, and so on. Okay. But it produces those. And on the basis of those, because that's pretty grim stuff to read, Agent 41 took out a loan of 432,362.095, because it's a real number, euros from Finance House 3. Nobody's going to read all that stuff. So we write a narrative that does it better. Okay. Now, these highlighted bits are annotations. So in the CCD, if you have an entity, for example, households, right? Or maybe farmers, I don't care, and you have some relations which say that farmers grow water-using crops in East Anglia. Okay, so you would have you would have a diagrammatic thing there. The evidence for that would be in the code, so you could just double-click on the bit there, and that would take you to the evidence for that feature of the design of your model. Okay. The model source code, okay, a lot of that is rules in this declarative rule-based agent modeling system. And those that are produced from the CCD automatically link back to the rules in the CCD, which of course then link back to your evidence. The rule which produces text outputs or any other kind of output for the logs also leaves its own link. So you link from that output to that output back. And as you might guess, we've now implemented it so that when you write your narrative, you link the bits that your narrative to the log reading, which then takes you back to the evidence. Now, let's be clear. Your clients, the policymakers, the civil servants, anybody but the analysts who are producing this stuff, don't want to go through all that. Right? And what's more, we want them to be able to do it incrementally. So what we're doing now, I'm not going to show it to you because there's too much to show and we've only got 20 minutes or so left, is I've said, look, what I want is a kind of executive summary. Okay, I'm going to show you a model about renewable energy take-up in Slovakia presently. And I said, look, what I want is just an executive summary that says that despite all the policy implementation, policy instruments that are being proposed, in this simulation we find that instead of the residents in blocks of flats supporting the use of renewable energy resources, what they actually want are gas-fired furnaces. Okay? Which is really what the policymakers don't want, because the gas is supplied by the Russians, and the Russians tend to use gas for political pressure. So the Slovaks don't really want that. No, 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 no. Nor does the rest of the EU want an EU member to have it. You got the idea. Okay, but that's what we got. And they would, and then they might say, and then they would say, for a graph of the results, click here. If you want an example of the decisions being made, click here, and so on. So that what they're doing is exploring that. And if they say, well, why did they behave like that? Right? Here you've got a bit of narrative. Right? This is all kind of HTML linked. Here you've got a bit of narrative. Where did this narrative come from? I mean, why did they do this? And this is a simulation output. They say, because they did it because there was this rule. Don't go through all that. No. This rule, and here's the evidence for it. Or maybe they don't even bother looking at the CCD. They just want to know the evidence. Here's the evidence. This describes the reasons why the model was implemented in such a way that the agents behaved in that way and gave you that result. Okay? Here it is. Blocks of flats can have this building F thing is it's insulation and double glazing, and it's essentially the heat loss, the U value of the building. Okay, which could be very good, good, medium, poor, or very poor. Right? I don't need to put in numbers for that. Right? I know because we got the evidence for it that roughly 2% are very good. And 15% are poor, and so on. We know roughly what the numbers are. And so what happened here, this was, the simulation actually went for about 500 time steps. Each of these represents a month. All right, so the whole thing was geared around that time step being a month. And what happened was the number of very good didn't change, and there was a reason for that. That was because it was very good. They didn't need to change. I mean, nobody was going to say, "Ooh, it's very good. We better make it poor." Right? The number that were yellow medium stayed the same and then dropped away. The number that were poor dropped, and this is the number of good ones. And the reason that they wanted to do that was because you can get a grant for changing your heating system, provided that you're in the good or very good range on heating insulation. Let's say you can't get a grant to put in a new heating system if it's all going to go out the window or through the roof. Okay. The other one we've got here is heating technologies. And this kind of, I only have 3 here. I just reduced it because for this talk, I didn't need to have that many. Now, they all started out with a district heating system, which is terribly inefficient. It's usually gas-fired. It's in a place, and then it goes by pipe to a variety of different buildings. And you can imagine the heat losses through the pipes as it goes on, right? Ecologically very, very unsound. But we started out with them all like that, because that's actually pretty much what was inherited from the Soviet era. Okay, and every time the price of gas went up, we just did blocks of flats here. The managers of blocks of flats would consult with the tenants, or the owners of the individual flats, and they would say, well, do we want to change anything? Well, if we know that the energy efficiency is poor or very poor or even medium, we won't get a grant. All we can do is improve energy efficiency. Shall we do it? Okay. And then when they did, then they would raise it. Now, one thing that's really interesting here is after a while, you begin to get those that have increased their energy efficiency, improved their energy efficiency, to the point where they can apply for grants to change their heating system and get a better heating system. And so what do they go for? They go for gas. Okay? They don't go for a renewable energy source. They go for gas. We'll look at the reasons why presently. Now this one is really, really interesting. Here, this is biofuel, biomass-fired furnaces. It went up, it went along, and then it went down. I don't know why yet. I'm going to find out. But I'm going to show you that we can find out. And look, it's important. You sometimes, maybe even frequently, get implausible results. There's nothing shameful about that. I mean, what you've done is you've put in the thing. Now, it may be a bug, right? Maybe some mistake you made in the modeling. Or it may be something that's in what they've told you about how the behavior is, or the way you've interpreted it. It doesn't make any difference as long as you can go back and find it, right, and change it. So this isn't a completed model. This isn't a perfect model. I didn't want to show you that. All right? This is a model where it has this anomaly. Okay? Another anomaly we get is that the individual flat owners contribute to a fund for each block of flats, which is used for, amongst other things, improving the energy efficiency and changing the heating systems and whatever else. And what we found was when they don't have enough in the kitty, in the simulation, they borrow, and that's correct, and that's pretty plausible. But then it keeps going up and up and up and up and up, and we know that doesn't happen. Now that's something to take back to the stakeholders. That's not a problem with the model. So that's one of those cases where you go back to the stakeholders and say, something else must be happening here. Okay? I will assume for the moment that there are some other things that happen, and the cost is power law distributed, you know, a few very large expenses, a lot of very small expenses, you know, and that may do it. And if you're happy with that, that's fine, but if we need to go further, then that's up to you to tell us. Okay, that's the end of that, because what I want to show you is some results and how I dealt with them. I'm looking for Excel here. Yeah, that's a good one. Okay. These are, this is sort of edited. What it actually looks like, this is what comes out of the, what we get from the models. Now you see, first thing is, flat dwellers have social attitudes. Okay? It's not a number. You know, we don't describe attitudes by number. Well, if you're a kind of econophysicist, you might, but you know, most of us in normal, everyday language don't. And so we have this. There are a few who are curmudgeonly. They wouldn't listen to anybody. They just go their own way down it. Most are socially engaged. And some have strong green principles, but not very many. Look, this is post-Soviet Slovakia. You know, they're not, green isn't a big deal. So that's the kind of stuff you get, and then you get a variety. These are the names of the rules that generated the outcomes. But let's look at this. Right? I've said we have our executive summary, and then we go to we want actually to describe some cases, just some examples, right? So the ones I've chosen here all relate to a block of flats called, block of flat number 6 of about 9 in the model. And you can see that they do various things. They send reminders for payments to various things. They take decisions. I'm just looking. They pay back their loans. They order efficiency improvement contracts and so on. But of course, looking at it like that isn't so good. So what one does is, oops, wrong one. That's from a talk we were having earlier. You write it as a narrative. Okay. And this is just a story. When TECO raised the price of gas at month 0 and so on, then the manager of the block of flats contracted for an inefficiency audit, and so it goes. Now down here, I started to talk about the way some of the residents voted, and the stories, they were Thomas Sabal, these are actually a couple of our colleagues' names. I just needed some names, rather than, you know, Agent 42 and so on. Both are socially engaged in a normal sort of way, neither strongly in favor of green technologies, but they were influenced by the ease of use and environmental friendliness of the green technology. But those who voted for the gas-fired furnace were less concerned with environmental friendliness and so on. So you get a story that a stakeholder can understand. Okay? And I haven't done it here, but these are then annotated back to back to these rules, right? And these rules are connected to the evidence for them via the code, the source code, and the CCD. So they can pick up incrementally the reasons why different kinds of decisions are taken and form a view. Okay? Now, I was talking in a meeting we had earlier about sometimes where they don't like the view. Right? It was a case where I was modeling the impact of a mining policy in rural South Africa and the consequences on the villages, because miners are full of HIV/AIDS in there, and they get past the HIV/AIDS, and the local authority wanted to have to build up the mining, because it was platinum, and they had big platinum reserves, and platinum price is very high because it's used in making computers and things. And they wanted to bring in these miners who were riddled with HIV/AIDS, and then because of the sexual practices which we modeled of the villagers, the HIV/AIDS would go through the villages, kill off the people, destroy the social networks, and whatever benefits were hoped for from bringing in the mining in the way of revenue coming in to pay for health care and all the rest of it, be more than offset by the death of parents, leaving orphan children and elderly who had no one to look after them and so on, and the cost of that. Okay. The local authority didn't like that. They really didn't like that. Right? So we had to come up with I said, okay, I tell your story. Actually, I think this is the right story, but I tell your story. So we eventually solved it by leaving out the sexual practices of the villagers and putting in the French WHO life tables instead of the South African ones to determine the probability of someone dying at any age. They said, yeah, okay, they were happy with that. It gave them their result. But there was an indicator, right? As you follow this policy, just follow the mortality realized, right? And it'll either be the French one, good luck, or it'll be the South African one. If it's the South African one, that coheres with our modeling of the sexual practices and the transmission of HIV/AIDS. I don't know what happened. I don't know what happened. Yeah. But that's the principle. You're telling the story, right? You're not telling them what to do. You're telling them the consequences of what some possible consequences of what they do. Right? And they will either find it plausible or implausible. They may find it plausible and dislike it so much, feel that, no, I really believe that my policy is the right policy. I don't care what your model says. Well, okay. Nothing you can do about that. Right? But the purpose of the model, in my work anyway, is to produce scenarios like that in a structured way, linked so that nobody who isn't the analyst ever needs to understand the whole model all at once. They just need to be, they have the facility, and we do provide a user interface for this, to enable them to explore different parts of it that are of most interest to them and see the consequences and follow out links and so on. And if there's something that isn't there, then we have to provide that later on. Okay? That's it.
So is there randomness in these models? And if so, do you then say this is the likelihood of such a scenario happening? Or how does this work?
Well, there are what we call magic facts. Those are the ones you pull out of a hat. And yeah, look, we can't get everything. Firstly, if you're building a model, you get to a point where, I don't have this information. So am I going to wait for 2 or 3 weeks while we get the information, or am I just going to stick something in, kind of placeholder to move on and ask for the information? And we do that. So when it's a placeholder, typically it's a random number generator, and if it's more than 0.6, you'll do it, and if it's less than 0.6, you won't, right? Then you might do a sensitivity analysis on it. Does it make any difference if it's 0.9 or 0.1? If it doesn't, forget it. You know, you've got it, but so what? If it does, then you need to get the evidence. So one of the things that, of course, modeling does is it leads you to the evidence you need to make a reasonable assessment of the policies that you're analyzing. Did you want to, shall I?
You can continue talking if you would like.
No, I've finished. I think I've said everything.
Okay.
Always leave them laughing.
Well, this is the bit where you stop and everybody claps.
Oh.